Imagine waking up to a bright, clear morning. The sun is shining, but by the time you walk home, you're caught in a massive thunderstorm. That sudden change in the atmosphere is what we call weather. It is the sky's short-term mood, shifting from hour to hour or day to day. But if a visitor asks what it's usually like in Uganda, you wouldn't describe a single afternoon downpour. You would tell them it is generally warm, with 2 rainy seasons. That reliable long-term pattern is our climate. To find that pattern, meteorologists record the conditions every single day and average them out over a long period, usually about 30 years. Climate is the sky's long-term personality. By systematically measuring the daily weather, scientists can uncover the steady patterns we depend on to plan our lives and grow our food. To track these patterns, we use a weather station. This is an outdoor laboratory where meteorologists use instruments to measure different elements of the atmosphere. A central part of any station is the Stevenson screen. It is a specialized wooden box designed to keep thermometers safe, providing an accurate reading. To get a true reading, the environment inside the box needs to stay balanced. The white paint reflects the sun's heat away, and those slatted sides allow fresh air to flow through the box while blocking out the rain. The box is also raised 1.2 meters off the ground. This is because soil and grass can soak up the sun and radiate heat upward. The legs keep the instruments high enough to avoid that extra warmth. These features ensure the thermometers inside measure the temperature of the actual air, rather than the direct heat from the sun or the ground. Other tools measure different elements. This anemometer uses spinning metal cups to catch the wind. As they spin, they allow us to calculate exactly how fast the wind is moving. Nearby, a rain gauge collects water in a cylinder. By checking how much water is inside after a storm, we record the rainfall in millimeters. These standardized, highly controlled instruments provide the hard data needed to track climate change. They give scientists a consistent, objective record of our atmosphere that lasts for decades. While instruments work on the ground, the weather itself often begins with the clouds. These form when rising warm air cools down, causing invisible water vapor to turn into tiny, visible droplets. If you see thin, feathery clouds high in the sky, you are looking at cirrus clouds. These are usually a sign that fair weather is on the way. But when clouds grow tall, dark, and thick, they become cumulonimbus. These are the massive storm clouds that will bring heavy rain, violent thunder, and lightning to the region. Around the Lake Victoria Basin, the sun aggressively heats the earth, which then warms the air above it. This hot air rises rapidly, cools, and drops heavy rain straight back down. This is called convectional rainfall. In the Rwenzori Mountains, the rain forms differently. Here, the physical height of the mountains forces the air to rise. As moist air blows in from the water, it hits the mountain and is forced up the slope. As it climbs, it cools and drops heavy rain on the front-facing side, known as the windward side. By the time that air crosses the peak and moves down the other side, it has lost its moisture. It descends as dry air, creating a rain shadow on the back of the mountain, or the leeward side. Because of these geographic features, different regions can experience very different daily weather, even if they are only a short distance apart. Meteorologists take all those daily readings and measurements and condense 30 years of information into a single tool, a climate graph. This graph helps us see the big picture. The red line across the top tracks the average temperature for each month, while the blue bars at the bottom show the average rainfall. Together, they reveal the pulse of a region's environment. This data is what allows farmers to plan their year. In wet areas with high rainfall bars, they can successfully grow water-heavy crops like matoke bananas. In drier regions where the graph shows very little rain, farmers know they must plant drought-resistant crops like sorghum to ensure a reliable harvest. Climate data also dictates how we build our communities. It informs the design of our homes, the height of our foundations, and the materials used to keep our roads passable during the wettest months of the year. You might check the weather to see if you need an umbrella today, but you build your entire life around the climate.